determinants and Cramer's rule. So if I am giving you a square by square matrix, and I'm just going to give you lots of random examples or random letters, I guess. We'll do A, C, B, D. And I ask you to find the determinant. It looks like absolute value bars. I'm just going to write ABS bars. And so if I ask you if I have A, B, C, D, like this, what I basically want you to do, at least on a 2 by 2 matrix, so if it's a 2 by 2 matrix, when you have absolute value bars, what that's asking you to do is basically do A times D, I can't write anything, minus B times C. So I go AD, BC, minus BC. Okay, so that is what the determinant is. Determinant. And you guys are going to have a terrible time spelling it because I'm awful at writing it. And I spelt it wrong up here. It's not determinate, determinant. Sorry, so I'm making it really, really confusing for you guys already. So the example they have in the book is if I just ask you, if you just see this on a paper, a lot of times I have kids like, I don't know what this means. What does it mean? Negative square root of 2. And I just have the bars around it. It looks like a matrix, but what it's asking you to do is take the square root of 2, this guy, times that guy, times negative square root of 2, minus, always minus, negative 4 times negative 3. So times those guys. And then you're just going to evaluate what those are. So the square root of 2 times the square root of 2, and it's negative, will be negative 2. Okay, if you wanted to go through about it, you could do 2 times 2 is 4, the square root of 4 is 2, and then you have a minus sign. Negative 4 times negative 3 is 12. Negative 2 minus 12 is negative 14. Okay, let's make sure that negative sign goes along with it. Okay, that is the determinant. The determinant is always a number. Determinant is a number. And I can only find determinants of square matrices. And then what we're going to also do is find minor matrices or minor determinants, minors for a 3 by 3 matrix is the only ones that you'll be asked to do. So I have negative 8, 0, 6, 4, negative 6, 7, negative 1, negative 3, and 5. So when I ask you to find a minor of one of these, what it will be denoted with is M, and it might look like 1, 1. So this is rows, and that's columns. So same thing. I wish my R's and my C's looked a little bit different. Okay, what that means is I'm basically going to rewrite the matrix, and I'm going to cross out whatever rows and columns it tells me to. Okay, so it tells me to cross out row 1, which is that guy, I forgot the in bracket, and column 1. So to find a minor in this, I will be given negative 6, 7, negative 3, 5. And I am finding the determinant of that. So what you do when you find these will be a 1-number answer. So I have negative 6 times 5 minus negative 3 times 7. Negative 6 times 5 is negative 30, minus a negative is going to be plus 21, and that will be negative 9. Okay, so we would write then M11 equals negative 9. Okay, I can ask you to find any one of them. There's only a few actual useful ones, but if I asked you to find M23, What you're going to do is rewrite your matrix first of all. I don't want an equal sign there. So I have negative 8, 0, 6, 4, negative 6, 7, negative 1, negative 3, 5. I like rewriting it multiple times so that I actually can see what's going on and not have tons and tons of little marks all over. So M2, 3 means I cross out row 2 and column 3. Okay, so this might be a little bit harder to see sometimes when I have marks in the middle. What that's asking you to do is find the determinant of the things you didn't cross out, and you write them basically in the same order. Okay, negative 8 times negative 3 will be positive 24, minus 0 will be 24. 0 times negative 1. Okay, so that's what the minors mean. Okay, they also do something around cofactors, which get kind of weird. I'm just going to give you, if I have some matrix A, which are always square, so square, I can find the determinant of that, and I think we will only do 3 by 3 matrices, so I'll give you kind of what that looks like on a 3 by 3 matrix. So it will be the determinant. Whoops. Well, I won't try to do that. Let's give you like an example with lots of letters. So I have A, B, C, D, E, F, G, H, I. Okay, so when I do that, I'm asking you to find the determinant. So what I'm going to do is, the way that they write it is you have A, 1, 1. So A means that it's of matrix A, has nothing to do with the fact that this is A. This is actually A, 1, 1. And I'm going to multiply that by the minor 1, 1. And then from that, I'm going to subtract A, 1, 2 times, whoops, M, 1, 2. And then I'm going to add to that, so pay attention to your signs, A, 1, 3 times M, 1, 3. So what that actually looks like, so A, 1, 1 is this guy, so maybe I'm going to actually write them in different colors. Okay, so the A's represent what element it is of the big matrix A. So A, 1, 1 is this guy. That's A. M, 1, 1 is where I'm going to cross those off, and that will be finding the determinant of E, F, H, I. Then I'm going to subtract from that. So I already messed up all my colors. Sorry about that. So colors mean absolutely nothing now. A12 is this guy. That's B. M12 is when I cross off row 1 and column 2. Okay, what I have left over are these guys. So I'm making it messier and messier. I'm sorry. And I have DF, GI, and then I add that back to A13, so row 1, column 3, that's C, and then for M13, I cross off the top and the third column, I'm sorry, and I would be left with DEGH. DEGH. And then we would actually find the determinant of that, so let's go through and do an actual example with some real numbers. So I have A equals negative 8, 0, 6, 4, negative 6, 7, negative 1, negative 3, 5. So I'm going to end up actually writing this one a few times. So what I'm going to actually do, so if I ask you to find the determinant of that, I'm just going to go ahead and write determinant bars around things and rewrite my 5. So the determinant of A is going to look like this. So what's going to happen, the first thing I do is I'm going to basically cross off these guys. The number that I have out front, or that I crossed with both lines, is that guy. That goes in front. Then I have what I have left over that I didn't cross off. So I have -6, 7, -3, and 5. Okay, I'm going to go ahead and move these red marks. Okay, and then I'm going to pick a different color, and I'm going to cross off and make a T now. The one that I crossed off is -0. I'm going to go through and treat it like I'm actually doing the work with 0. If you have to have a 0, you can kind of ignore this whole term. But I'm going to do it just so you can see what's actually going to happen each time. Then the things that I didn't cross off are the 4, 7, -1, and 5 in bars. I'm going to get rid of those green marks now. Okay, and then I'm going to make a T across the top again. The number that I had that I touched on both of them is going to be a +6 in bars. I have negative, oops, sorry, not negative. The things I didn't cross off are 4, -6, -1, -3. So now what I'm going to do, and this is what I'm going to use to find the determinant of a 3 by 3 matrix. So hopefully I already told you that, but I don't think I did for some reason. Now I'm going to find the determinants here. So I have -8, and then in parentheses I'll have -6 times 5 minus -3 times 7. Then I have -0. I'm just going through this. If it's 0, basically you can cross this whole thing out. But I would have 4 times 5 minus -1 times 7. Then I would have +6 times 4 times -3 minus -1 times -6. So when I actually go through and do that, I would just use my order of operations. So I'll have -8 times, that will be -30 plus 21. This is all going to be 0 at this point. At this point, you can just kind of cross it out. -12, and that will be -6. So I'll have -8 minus times -9. Then I would have the -0 guy in there, and then +6 times -18. Okay, so I have +72 minus 0 minus 108. 72 minus 108 gives me -36. And my determinant for A, and I can just write this as -36. If you want to find determinants in your calculator, you go into second matrix, go over to math, determinant is your first option. I'm hoping that we have a square matrix in here, so we have a 2 by 2, and it spits out -1. This is not a matrix, this is just an answer. So this is how you would do it on those guys. I'm going to write down the rules for you, which are found on page 536 and 37. And these are Cramer's rules. The first one we're going to do is Cramer's rule for 2 by 2 matrices. I'm just going to write for 2 by 2s. Okay, so I have a systems of equations that would look like a1x plus b1y. a1 and b1 are just coefficients, is equal to some constant. Then on my next line, I have a2x plus b2y equals c2. Whenever I use a c, an a, or a b, this is where they're coming from, is what number they're in front of, which variable they're in front of. In order to solve for x, then, Kramer, this fancy smart guy, used what he called x equals dx over d, and y equals dy over d. Now, how he used this is he would say dx, or actually it's easier to label d first. So d is the coefficient matrix, the determinant of the coefficient matrix, I'm sorry. I have a1, b1, a2, b2. dx is, the b's are still where the b's kind of live. So if you kind of just say like a, b, c are my different columns, but I have c1 and c2 instead of a's. So pay attention to the order that it lists things in. Okay, And then I have what he called dy, and that was a1, a2, and c1, c2. So you'll have to find some determinants. The determinant for any of them, or this determinant specifically, cannot equal 0. That doesn't even look like a d. D cannot equal 0. Okay, because that would mean that we were dividing by 0, so that can't work out. So what we're going to do in order to solve these is if I gave you a system of equations, so example, they have 2x plus 5y equals 7, and 5x minus 2y equals negative 3. I'm going to make these three different matrices out of them. So my d is equal to my coefficients. So that would be 2, 5, 5, negative 2. My dx will be, so my C column is 7 and negative 3. That goes in there first, and the b's stay in the same place. My b's are 5 and negative 2. These are all, they look almost the same. They are different though, so do pay attention to these orders. For dy, my A column stays the same. My A column is a 2 and a 5. And then I have my C column in my second column, which is a 7 and a negative 3. So then what we're going to do to solve our x, I have the determinant. So I'm going to go ahead and actually find the determinants for each of these now. So I would have 2 times negative 2 minus 5 times 5. So that will equal negative 4 minus 25, which will equal negative 29. My dx will be 7 times negative 2 minus negative 3 times 5. That will be negative 14 plus 15, which will be 1. So I'm going to write like dx equals 1 and d equals negative 29. My dy would be 2 times negative 3 minus 7 times 5. That's negative 6 minus 35, which is negative 41. So dy. Okay, and then to find my x is equal to dx over d. So I'm going to write it out, dx over d, which is equal to 1 over negative 29. So that is what x equals. My y is equal to dy over d. dy is negative 41 over negative 29, and that would make those guys positive. And then I could write it as an xy pair if I wanted to. So I have negative 1 over 29 and 41 over 29. You might have thought that looked really dirty. And now we're going to do 3 by 3 matrices. So we now have Kramer's rule for 3 by 3s. Okay, so what that would look like if I had just a generic old form of a systems of equations, I would have a1x plus b1y plus c1z equals d1. And then I would have a2x plus b2y plus c2z equals d2. And then I have a3x plus b3y plus c3z equals d3. So now what I would have, basically the same basic things that I would have x equals dx over d, y equals dy over d, and z equals dz over d. Okay, your plain old d is the same way that it was before. It is going to be the determinant of the coefficient one. So d is a1, b1, c1. A2, B2, C2, and A3, B3, C3. Now, so just pay attention to your patterning again. I have dx, so x first. dx is going to be the determinant. I'm going to have my d's in the first column. So I have d1, d2, d3. The other one are b's and c's. So b1, c1, b2, c2, and b3, c3. dy is going to be a1. So I have a's, d's, and c's. It's all going to be 1, 2, 3 all the way down. So just rewrite that. So just remember basically the top row is the only one you have to remember, and then just go straight down with that. D2, C2, A3, D3, C3. DZ is going to be the D's on the right-hand side. I will have the A, B, D's. Okay, so 1, 2, 1. No, they're all 1, sorry. Then I have A's, 2 and 3, B2, B3, and D2, D3. Okay, again, we have the same basic rule. D cannot equal 0 because then I would be dividing by 0. So now if I gave you a nice systems of equations that looks like x minus 3y plus 7z equals 13. And then I have x plus y plus z equals 1. And x minus 2y plus 3z equals 4. So in order to go through and do this, I set up my matrices first. So I'm just going to list them. You're just going to list them somewhere, and probably, honestly, you will do the determinants piece in your calculator. Okay, so my determinant is, and so basically I just want to see this next step set up, and then you can do it in your calculator. So D, my plain old D with no subscripts, is 1, negative 3, 7, 1, 1, 1, 1, negative 2, 3. My dx is equal to my D column first. So I have 13, 1, 4. Then I have my B column. So negative 3, 1, negative 2. And then I have my C column, which is 7, 1, 3. And then I have my dy. My dy is ADC's in my column, so my A is 1, 1, 1. My D's is 13, 1, 4. My C column is 7, 1, 3. My DZ is equal to my ABDs, so A's are my 1, 1, 1. My B's are my negative 3, 1, negative 2. And my D column is 13, 1, 4. Okay, so my plain old, my coefficient matrix, which is my D, is the only one that doesn't have my answer one in it. So it doesn't have my D's in it. Then what we're going to do is we're going to set those up. So I'm going to list out my dx over d. What I'm going to go do is name them in my calculator. And I'm going to go into my matrix. I'm going to go over to my edit, and then I'm going to type in these 4 matrices into my calculator. So I'm going to pause it and then do that. And then I'm going to go over to my math menu in my matrices menu. I'm going to click determinant, and I'm going to find that of matrix A. So I'm going to hit enter. And the one that I typed in matrix D. So my determinant of matrix D is negative 10. Now I'm going to go in and type matrix dx in there. Okay, and then I retyped in a new matrix into matrix A, and I got 23.3. And just because I think that's a weird number to get, I went back into my matrix menu, And if I go down, I actually see right here, I have a 0.3, not a -3. So I did that one wrong. So I'm going to quit out of there. I'm going to enter again, and now I get 20. So over here, I type in 20, or I write 20 now, just to keep track of it. So anytime I get a weird number, I just want to go back and definitely just recheck everything I typed in. So now I'm going to go type in dy. So now I'm finding the determinant of matrix y. So that gave me -6. And now I'm going to go do it for dz as well. Okay, so I quit out of there. I'm going to find that same matrix, the determinant of z now, and I get -24. Okay, remember how we find the determinant of a 3 by 3 matrix is we're crossing things out and making like a very long list of things. And then I'm going to do dx over d. dx was 20 over d, which was -10. That gives me -2. So that means that x equals 2. And then I have y equals dy over d. dy is -6 over -10. That will be positive 0.6 or 6 over 10, however you want to write it. And then I have z is dz over d. dz is -24 over -10. That would be positive 2.4. You can write it as a fraction as well. They write it as 3/5 and 12/5. Okay, it really doesn't matter at that point. For the 3 by 3 matrices on your homework, you can go ahead and do those on for the matrices. If it says evaluate, I do want you to do it by hand. If it says solve using Kramer's rule, you can do the 2 by 2s. Please do those by hand so you just get some practice with them. And then do the 3 by 3s in the calculator is what I would suggest. So I want you to do numbers 1 through 41 odds on page 538, and they shouldn't be too bad. The harder ones, the ones that have 3 equations in them, you can use your calculators. I'm okay with that. Some of them get kind of funny. Some of them have some x's in them. So you'll just get probably multiple terms with x's in your answers.